Okay, good morning everyone. This is gonna be another lesson. This time we're gonna check out two plugins, maybe almost three, with the Weaverbird to build something crazy. It's gonna look maybe something like this, or it depends on whatever kind of things you do with it. But this approach, again, is quite general, and I feel like at least parts of this might be very useful in any kind of project. So I'm here on this is the finished part. This is where I give it some colors. We might not dig into that, but if we manage to do the whole thing, this is quite easy. So when I disable that, I'll go back, and here you see a plugin called Dendro, and this is meant to work with any kind of geometry. If I show you the tab, it's up here, and you can generate a volume, meaning a mesh, out of curves, of course mesh, points, and even B-wraps. So if you have something like some crazy curves like this, or just points, point cloud, or a mesh, and you want to merge it together with something, it's so much better to use this approach, where you just say there's a radius around every single object, like this. I mean the curves, the points, or the mesh, or the B-wrap. And then in that radius, you're searching for an ISO value, which kind of makes sense to still be inside of a new volume. And then this ISO value gives you some kind of ISO surface, and then you can smoothen it out. So that's what I'm doing over here. So if I just show you over here, this is the rough volume. You can see that some edges are a little bit jagged, or something is not quite smooth, and then you can smoothen it out using these components, or then you can convert it into mesh, and that means it's going to be smoothened out even more. You can put more divisions in there. If you hit Ctrl M, you can see that now there's like very dense mesh, and you can further optimize it over here. So this can get really computer intensive. You can see that this component computes for 1.2 seconds, which is kind of like, if you worked for Zaha Hadid, she would say, no, this script is not good, because if it's over 1 second, it's too much for her. Just a joke, but I've heard it many times. If you want to see how things are, how fast each component is, turn on the profiler in display canvas widget profiler. I know you cannot see it, but it's there. Okay, so this is a very cool tool. This approach for giving anything a volume is called Maching cubes. And I believe in the description of this video there's a very cool explainer video from Coding Adventures, which is a very cool channel on YouTube, so check it out. And if you have further questions, we can discuss it later on Teams. So this is the second part, and the first part, when I disable this, because I don't really have the power to compute all of it at once. The first part is something we're gonna repeat a little bit. It's again attractors, but this time it's gonna be more fancy attractors with the native Grasshopper components. Damn, I hope my audio is okay, but now I see no lag. Also, I hope you can still get something from this. So there's some attractors here, and we're gonna do something which is called a loop in here. That's the Anemone plugin, and this is something which helps you overcome a huge obstacle in Grasshopper, because in here we are actually getting a real-time loop of this part of the script, and that's something really you cannot do without this plugin. And like most of the time, this doesn't mean that you can do proper loops in your script, but for small things like moving a point in a vector field, it's quite useful. So I'm just gonna show you how does it work. So if I just make this run and restart it, you can see that the points are running from one attractor over here. This is repulsive, and this one is sucking the energy, so all of them are like trying to get over here. So this is just two attractors working when I enable this one, which is fairly huge. Everything starts to spin real fast because this one has a lot of energy. And there's another one, if I enable this one, everything starts to spin even in the second direction. So you can do all sorts of crazy shapes with this. And then I stop the loop, so my computer doesn't crash, and now I have some crazy curves, and I can really, you know, it seems like this is going to be hard to work with in a normal way. So this is where the Maching cubes algorithm is very useful, because you can say, hey, every curve has some kind of radius around it, and that's what I want to enclose in a volume. So this is something we're going to try to do today. If you have any questions, just put them into the comments. I hope you have the plugins. If there's a problem with plugins, I'll show you later on the Teams, because there's going to be shared screen, not like this on YouTube. Okay, so let's jump into this in a new file. Okay, I'm gonna place in some populate. Let's do populate 3D, and I'm gonna try to keep everything in the size of this grid so that we have the same units. It's later on very important for the Dendro to work properly. So I'm gonna do a box, and I'm gonna set this to box in my Rhino, so approximately something like, okay, once more, something like this, so like half of the space, a box like this. So when I feed it to populate, I'm gonna give you the names, bifocals, here we go. So when I feed it to the populate, I have some cool points in my space, and let's now focus on the attraction on the vector field. So if you go to the V tab, there's field section, and let's start with point charge and try to build a decent vector field. So point charge is a very cool thing. Otherwise it works like you know, attractors with points we worked with before, but in this case, so we can extract parameter, just right click and set one point. I'm going to place this one over here, and then it's very important to play with the charge and decay values. So I'm gonna put in here a slider from -2 with 2 decimal numbers, comma dot dot all the way to 2. So -2 is the minimum, +2 is the maximum. I'm gonna put it around 1, and this is gonna be my charge. So this one is repulsive. You can see that the arrows go outside of it. And now I can create another slider for the decay. By default it's 2, and that might ring a bell because you know, the power of 2 is usually in the equation for distance for anything which works with the field. So we're gonna create a slider from going from 0.0000001, something very small, almost 0, all the way to I would say 4, maybe 6, yeah, because we don't want the exponent to be too big. So if this decay is really small, that means the point affects everything around itself. Like it very smoothly decays off, but it has a lot of like the area where it works is very huge. If I, on the other hand, make it a big exponent, bigger than 2, some energy is just around it, but the points won't be affected that much. Okay, so we have the first points, and I believe it's fun to have 2 of them. So I'm going to right click on the second point. I'm going to say set point, and I'm going to place the other one over here. So I have 2 points, and this one is going to be negative, so I'm going to do like minus 1 point something. Again, if the decay is big, all these points will be influenced. That's what we want. And the funny thing about these components in here is that they are producing something which is called field. The data type of this, if we put it into a panel, it's called field. And like it looks kind of nasty. It's grasshopper.kernel.types.gh fields, you know, programmer stuff. But all we need to do is just merge the fields together. So there's merge and break fields, could be useful. And this is the moment where you can use shift to put 2 cables into one component. So now we have one field with 2 elements. That's exactly what we want. And now let's check out all the other things in here, because it's kind of useful. So first we can do evaluate field, because this is like the most useful one. If we have a field as this, then we can ask for the value and also a vector in any specific point. So I can put in here into the P, I can come up with my own point. I can place it somewhere where I want, maybe over here, and make it visible. So here's my point, and I can ask this huge field, what is the value over here in this one point. So the value of that field is going to be 2.3, and the vector, I don't see it, but I use vector display over here to, so this is the point and this is the vector. It's called tensor, and we can see that in here the point would travel like that. That kind of makes sense because this point is repulsing and this one is sucking the energy, so this guy over here is quite okay. Well, and if I now replace this point, one point, with all the points I have, I'm going to see a lot of vectors, and now you can see that it kind of makes sense. All the points are traveling towards here, and that's exactly what we need. So this is how vector field works. It's always fun to add some more interesting vector field components, like actually I like the spin force the most. Line charge and vector force are kind of the same, but to be honest, yeah, I don't use them that much. So I'm gonna add spin force, and spin force needs not a point but a plane. So I'm gonna repurpose this point here, set one point, and I'm gonna place it maybe somewhere around here, and I'm gonna say that this is in the horizontal plane, so XY plane, and this is my spin force. By default it's kind of small, so this might not have much influence, but in this case, like in points, I'm playing with the decay a lot, but in spin force I kind of find out that it's easier to play with the strength and radius and keep the decay on 2. So I'm gonna have the sum slider here with the strength, If it's negative, it flips the direction. So if I zoom in over here, you can see now it's pointing clockwise, and when I do like that, it's counterclockwise. That's cool to know. So I'm gonna do it, make it stronger a little bit, and then radius. I'm gonna give it some radius so that it's big enough for this situation over here. So let's do something like 120. Okay, this grid size is 200, so I'm gonna do something from 20 dot 200. So now my slider goes like this. 20 is nice but small, and 200 is quite huge. Okay, so when I add this to the vector field, to the merge fields, you're gonna see some change of direction probably. So with shift again, and not much change, but this guy over here probably changed a little bit. I'm gonna increase this. See, it goes smaller. So we're already influencing this, and when I grab this point, I can place it closer, and you're gonna see the points really change their direction. See this one? So again, we can of course play with the decay, but no, I'm gonna keep this for later. So this is like something we skipped over, and I believe it's good to be able to use these components, because when you have more tractors than one, this is very convenient to use. Okay, so this is our field, this is our evaluate field. Maybe later on it's fun to check out maybe in direction display, or you know, these components over here. I'm not gonna jump into it right now, because what we need to do is build the loop now so that our points are moving in real time. So end of part 1, let's go to part 2. So if you double click and type loop, you should see this loop start and loop end. Those are components from a plugin called Anemone, or Anemone. I like, yeah, sorry for my English here. So in here, I'm using the classical loop. There's a fast loop, kind of feel the classical is better. And it works like this. You have this loop start, and there's another component called loop end. And what you do is you connect those two components with this stretch arrow. It also generates this weird wire. It's a special kind of wire, and that means this is gonna be looped. So whatever comes in here in the D0 is gonna be eventually ending over here in D0 again, and then it's not gonna directly go to this output, but it's gonna loop again into this D0, so it's gonna flow out over here. So this gives me opportunity to do loops in here. And one more important thing, there's this loop ending feature, so let's build that. So I'm gonna put there switch so that we can stop the loop. So if this is true, the loop stops. This is loop counter, a very important thing. Actually, we're not gonna use it today, but sometimes you need to know how many times the loop already happened, and based on that you maybe add one and do something different for each loop. So this is where you get your loop counter. And for our purpose today, we're gonna use this repeat. When it's on 0, it's gonna repeat infinitely, and you've seen that this script might be pretty heavy, so we're gonna limit this to I don't know, 100 maybe. We can always increase this. Sorry. Okay, so this is our loop count, and one more thing, this T stands for trigger, and that's to restart the loop. So a very useful thing. In this case, I'm going to place a button in there so I can just click once. I don't have to double click. So this is what restarts the loop. Well, this now looks like a pretty okay loop. We can do all sorts of things, and whatever we do inside of this D0 and D0 here, it's gonna be happening 100 times, and it needs some input like the initial one, so that's gonna be our points, right? Then we're gonna move the points in here, but the movement is not going to be same for every single loop, because if the point moves in the vector field, it's going to be on a different place of that field, right? And that means when we measure its position, its field strength, and also the vector, we're going to have a different number for every iteration of the loop. So let's build that. I'm just going to borrow this. And I'm gonna say that the points go here, the same like it was before, right? But now we have them in the loop, and I believe this should go in there as well, right? We want to see the vector in there on the tip, and now the only thing we want to do is move that vector, that point, I guess. So my point coming from D0 is going to be moved using this vector. The funny thing is, these vectors might get really small because of the decay and because of the distance to each tractor. So I think I want to control this over here. So I'm going to place their multiplication, and I'm going to make a slider going from -50 to 50. So that I have some control over this, you know. So if it's minus, it's actually making the vectors negative, going the other way pretty fast. So I think I'm gonna decrease it a little bit like this. And well, these are the vectors we're gonna use for our points. So now our points, this is like what happened in the first loop. I need a little bit more space here. So let's place this here, and this is it. I'm just asking every single point which is coming out of the D0 to ask for its field value, namely the vector, right? And then multiplying that vector by something so that it's, you know, visible and fast enough, and then using that vector to move exactly the D0 point. And when I connect this over here to D0, it should start moving. So what happened to our points? They all kind of got sucked into this point, and now they're stuck over there. So I'm going to increase this a little bit. Yeah, we reached our limit of 100. So when I restart this, yeah, it seems like this tractor is too strong for us. Yeah, so probably we're gonna decrease the power of this one. So I'm gonna say -0.2, and let's rerun this. Okay, then this other one is too strong as well, so I'm going to say 0.2 in here as well, and restart it again. Oh yeah, now it's, some of them are getting stuck over here, and it gets large over here. So this is exactly what I wanted, something like semi-random movement, but it's all based on the fields. Great. So when I stop the loop over here, let's check out the output. So this is now set on constant output. That means we are just getting 100 points, all the points which are in the current situation. So you can see that they are at the end of the vectors, like after the movement. This is our output. But there's another type of output. It's like when you turn on record data. I'm gonna restart this. Okay. Oh yeah, I have to enable the thing, and now restarting, and this records the data for every single point. So we're gonna get a lot of points. So I'm gonna stop it first before we start doing something, but this shape seems to be pretty interesting to me, so let's try to build something with that shape. So if we have constant record, now you can see that we have 100 points in every single branch for every single iteration of the loop. So you can see that only 63 loops happened. That's why this counter is going to be on 63. So I have 63 branches of data. I'm going to show you in Prague Viewer. And that means like if I want to do like a trajectory curve from all these points, this is not going to work so nicely. I'm going to show you if we try to interpolate a curve through all these points, it's going to do something very messy because, like, you know, see the curves? It's actually a curve coming through all the first points in this thing, and then all the second points from the second iteration. So the data tree is not helping us. We have a branch for every single iteration, and that's not what we want. So in order to make this data like focusing on every single point, I mean, like, I want to know the trajectory of the first point, I need to use flip matrix, and this is a very useful component. So let's check out first what does it do with the data tree. So initially we had I think 64 branches. The last one is named 63, right? And there's 100 things in each branch. And when I use the flip matrix, it's gonna look quite different. So now we have 100 branch, and there's always 64 things in that branch. And that's the crucial difference, because now this data is looking at the trajectory of the first point. That's 64 iterations of that point. So when I use this data for my interpolate curve, I have a nice curve which is following the trajectory of each point. I believe now it's time to hide the box because it's getting in my view and I don't like it. So hide this. Maybe we can even hide this whole thing, and maybe just the vectors can be visible at the end, so this kind of looks nice. And since my loop is stopped, I know that this data is not gonna change. In order to be able to stop the data, there's a thing called data dump, like a huge dam of water. I'm not quite used to using it, but let's do it today. So whatever comes in here is going to be stopped. If I start changing this curve, the output is still going to be the same until I click this button, and now it's like running. So yeah. So now it's telling me it's up to date. So now I have all these curves here. One more thing before we continue. It happened to me once. I want to clean the data before we start doing some crazy stuff with it. So if there was a empty curve or something like not working curve, it might happen. That's gonna get deleted. And one more thing, I want to flatten the data here because I'm interested only in the long list of curves. Just for your understanding, I'm just going to place it here. You can see that over here I have all 100 curves, right? And if it's not flattened, it looks like this. Every single curve is in its branch. That was useful before when we wanted to combine all the points together to one curve, but now it's not needed. So I'm going to flatten it over here. So now I have this flat list, all curves together, and you know I'm gonna curve component over here so that I know what's the output of this part of the script. So we have two parts. This is our field, and that field affects our points in this loop, and that's why they can travel. You can play with this, but I'm going to continue with other stuff. So you know, you can group it like you want, and I'm just going to do this, another curve, so that I can do some other connections later on. After finishing a part of your script, it's always useful to do at least one of them, but I kind of figure out that sometimes you want to put some code in the middle, and you know, it's hard to move all the components, so this is a good habit. So right now I have 100 curves. Nice. I hope there's going to be some little hole in the middle, and then some really cool ends maybe here. I'm not sure. We're going to see how it's going to work. So let's move on to the Dendro. So that's over here. So this is another plugin working with another approach. As I said, it's called Marching Cubes. Sorry, I need to drink this. Marching cubes are something which actually fills the space with small boxes. So those boxes, oh shit, something went wrong. Okay. Okay, this is weird. YouTube just said that something went wrong, but I seem to be still streaming. Maybe type something into the comments, please, if you can still hear me. But I think I should continue. Okay. Well, it seems like it's back on. Okay, cool. Great. So Dendro, back to Dendro. So imagine we're gonna fill this whole space with little cubes. We can do it real quick with box array, just for your imagination. So box array over here, and I'm gonna place just a little box again. So I'm gonna do domain box maybe. So this is geometry, and I need okay, let's do our own domain. I'm gonna just type it out. This is just for explanation. So let's say 10 so -5 capital TO 5. So this is my domain for all the 3 directions. So this is my box over here, a small one, and then I'm using box array. I'm gonna use the, what is this? Yeah, this is the cell, so I'm gonna use the same box for cell, and I have like boxes in the space, and I'm gonna try to bump it up to 20 cubed. So 20 times 20, you know, times 20, and this I hope doesn't freeze. It's a lot of cubes, so those cubes won't be visible. Those cubes won't be visible, but you have to know that they are there, and seeing 20 cubed, like 20 times 20 times 20 cubes, it already is the hardest component in our script. And if I bump this into 50, this is like exponential, right? Now it takes 1.4 seconds. So make sure that you don't put huge numbers into Dendro, because you can get as crazy as this. So I'm gonna just bump this down to 10. So we're gonna fill the space with cubes, and then every single point or every single place we decide that we want to be part of this volume is gonna ask those cubes, hey cubes, am I inside one of you? And if yes, on which edge am I? And this question can have, I believe, 128 answers, like you're on edge A and edge B and maybe a little bit on edge C, and it's a little bit like it's finite number of answers. So this finite number of answers is going to be answered, and then every single box from this huge cube of boxes is going to be deleted or cut it in the proper way so that the volume is just the part of the cube which belongs to the shape. I hope this makes sense. If not, just check out that video, because from Coding Adventures it's very nicely done. Just make sure you know that you'll be filling the space with cubes, and this might get really nasty on your computer. So I'm going to place this away, and let's start with volumes, and we want to do curve to volume. So I have my curves here, I put it over here, and the most important thing in this component is the radius. So I'm gonna set the radius, like if you see the scale of my object over here, I'm gonna try, like, this is 10 units, right? So I'm gonna try 10. Or maybe I'm gonna try 20. Okay, so my radius is 20. You won't see nothing yet because this volume needs the settings. That's where we decide the size of the cubes. So if you go again in context, create settings, this is the important component. So when I connect this right away in there, I might get into trouble because I don't know what's the size of the cubes. And remember, I did my cubes with 10 size, like as the side of this cube, and this is set to 1. So if we were to, compute a box which would contain small boxes, small cubes, with size 1 for this whole thing, that would be crazy. So I'm gonna say 10. And I'm gonna hope that this is gonna be all right. So okay, 10 for the size. The rest is not so important right now. We can touch on that later. And I'm gonna try this. Oh yeah, cool. So it worked. I have a little hole here. Yeah, cool. And I have some bumpy edges over here. Yeah. So this is like a, I don't know. It looks like a, let's say, a donut. Okay, so this worked, but sometimes I know that in some cases the radius needs to be at least 33% of the cube size, because if you're asking a cube of this size, if it fits into something which has smaller radius than that, it actually doesn't make sense. So sometimes this component doesn't it becomes orange and says, hey, the radius has to be of some size. So I'm gonna try to make it a little bit smaller, but we're gonna reach that limit pretty soon, I guess. See, yeah, this is the moment. Now it says the radius might be at least 33% larger than the voxel size. So you can run into problems like that, and we know that we don't want to have much smaller cubes because that might be problematic. So at 18 it looks kind of okay, but if these two numbers are too close to each other, we're gonna have bumpy mesh. One more thing, this by default is a kind of special type of data. If you put it into a panel, it says Dendro volume, which is not a normal data type, and that's why you have this volume components in here. It has a black hexagon, so it's a basic data type. So if I feed it over here, it's working, but if you look at it, it looks like a mesh, and we can prove that by just adding a component which is called mesh after that, and this is gonna translate nicely. So now you can see that there are still the cubes kind of visible. See, there's cubes everywhere. It's like, you know, the mesh is visually originating from something which was a grid of boxes, and to make this you know, unwanted effect go away, we usually smoothen this thing. So in filters, there's this smooth volume component which kind of works on the volume. So let's keep the mesh out of the equation now. You know what, I'm gonna keep these two, and I'm gonna just smoothen it over here. And you know, the smoothing, this takes some time, so it's almost 1 second, so you know, I would be almost mad. If I now uncheck the preview for this and even these two, what? Oh yeah, that was nice. Okay, I think I'm having some trouble with my computer after the update, but I hope you still hear me. So if I uncheck the preview, over here we don't see the grid of the mesh, but if I just take these two guys again, move them over here and enable that mesh preview, you're gonna see that now it's, well, a little bit better. It's smoother, some of the bumpy parts are away, but to be honest, like my so far like experience with this smoother is not so, like, it's not smoothing that much, but it's good to have it there because it's native to the voxels. So maybe it gets some problems flatten out. And that's why after this I'm going to be using another plugin which is called Weaverbird. So I'm going to say CAD4 Clark's subdivision. It's another plugin called Weaverbird, and you also have a link to that. And I kind of like this smoothing algorithms here. There's a lot of them, and even like I mean, subdivision and smoothing is here, both pretty powerful. So when I put this into my subdivision, by default it's set to level 2, and you're gonna see that the grid is even finer, and the edges, see, they are smoother, nicer. So when this gets out of the way, you're gonna see a very nice mesh already. So just make sure you cast it to a mesh component before you put it into Weaverbird. So you know, this still contains this Dendro volume, which might be problematic for this input to make work. Some components are able to rework it into mesh, but this is like a proper statement. This is a mesh, work with this as a mesh. Okay, so we have this shape here. One more thing, after this subdivision we can do this like place in smoothing for even more nice mesh, even nicer mesh, I mean. You can see that some of the edges have been moved a little bit, but like, you know, this is the original mesh. With this smoothing, it always like shrinks a little bit, but that might be good for some cases. So over here there has been a lot of ends, and now it's pretty smooth, so that's useful. And I guess it's time for doing the preview colors, because that might be the last part. So okay, we have this crazy shape. Make sure that you don't enable the loop, because this takes like almost a second and that would totally crash. So that's why we have this separation with this data dump over here. Yeah, that's what I wanted to say. I more usually use the fact that you can just, you know, disable this component and then change the curves in the loop, and then just enable that one component over here, because you know that all of this is not going to compute because there's no data coming in. Okay, Great. So the last thing is the colors. And to be honest, with mesh, it's kind of different than what we did before. So I want to show that as well. Um, this is a very huge mesh. It has a lot of points. And in mesh, you have mesh spray, where you say, hey, there's a few points here, and I want to be like spraying a color from these points onto that mesh, and the result is a mesh which has colors. There's some interpolation here. I like the square the most, but it's not quite like, it doesn't produce very nice outputs. So much more nicer is called mesh colors, but this guy needs to have a color for every single point. So when I put this in, there's a pattern of points, and it just produces this ridiculous ridiculous color. Like, it looks like a pattern, but since the points are not ordered in some particular way, it kind of is gibberish. So let's say we want to color this mesh based on some proximity to a number. Again, the thing like attractor. Okay, yeah, I get it. That was just to Ben and Matush. Yeah, just you can rewatch the rest of it later. Okay, so back to the colors. I want to use the gradient tool again, so I'm gonna have this one, and I'm gonna put on some nice preset, maybe this colorful one. And what I want to do is, I want to calculate for every single point in this mesh. I need to calculate the color, because if I don't have enough colors, then that pattern of colors is gonna repeat, and I don't know the order of points. So basically, I can just pick a point. I'm gonna pick a point by just placing it over here, and I'm gonna deconstruct that the mesh. So mesh deconstruct, and this might take a while again, but it's not so bad. So now I have access to all the points in here, so I could easily, because calculating distance is just one big square root, so I can just calculate how far they are from that point, and based on that they're gonna get a color. So again, in here I need bounds. So what's the domain of all the distances? It seems to be from 20 to 389. I need to deconstruct that domain. So here we go. And those are going to be the limits for the colors. So those two numbers go here, and the distances themselves then can nicely go to t. I don't like how it's aligned, so I'm going to just place it like this. And now I have 59,000 points, and that's what I'm going to give this mesh colors input. And now it's nice and smooth, so I can just disable the preview for this. And this takes 200 milliseconds almost, so when I move this point, it's not gonna be almost super smooth, but yeah, it's gonna update pretty quickly, so I can do all sorts of rainbows on my donut. Okay, yeah. And if you don't, at some point, if you don't like the mesh, like the curves on it, you can either switch to rendered, which might be a little bit heavy on my computer, but there's also this option. If you hit Ctrl M, the grid disappears, so you're just gonna see the colors of the mesh, not the grid. Okay, so if there are not big questions, so I can see one. Okay, there's a question from David. It seems like I think I'm using version 0.4 of Anemone. If you have trouble with that, we need screen sharing. So let's go to Teams and try to optimize it there. But yeah, if there are not big questions now for the YouTube, I think we can finish this lesson here and go to Teams to discuss issues like that. I hope it was interesting. And that's it. Okay, IR out. I just realized that this animal is called IR. That's funny. Okay, so the discussion on Teams starts in 2 minutes, so let's meet there and discuss the trouble with the plugins. Okay, I'll upload this file again on our website, so see you then. Bye.